So there's one other rule I'd like to go over. I've done the chain rule, now I'm going to do the product rule. F of x times g of x. What if you want d of dx of that? The only reason I'm doing this one in addition is because the proof is kind of neat. So it's purely for fun. So if you don't care about the proof, then just look up the rule, but it's f prime of x times g of x plus g prime of x times f of x. That's the answer. You're done. But let me show you this neat proof. I'm not going to go over any of the other rules. Just look them up. I just like this one. So we're trying to find d dx of f of x times g of x. Let me introduce a new function. I'm going to say z of x equals f of x times g of x. It's fairly trivial, and I'm about to get rid of z again. I'm only going to use it for a couple lines, and then it's forever gone. It's just to make the next part more clear. So let's find d dx of z of x. Well, let's write that out in limit notation. It's the limit as h goes to 0, see I use both, of z of x plus h minus z of x all over h. And now our good friend z gets to go away, because there's our z, so it's just f of x plus h times g of x plus h minus f of x times g of x all over h. And z is gone. Long live z. So what was even the point of doing that? What is f of x times g of x plus h minus f of x times g of x plus h? That's 0, it's just something divided by itself. In other words, I can take this whole thing right here and just shove it right in there. Because it's 0 anyway, it's just something minus something. No matter what it is, it's 0, isn't it? I'm going to stop writing limit just so I have more space. So we had f of x plus h times g of x plus h, and then the thing that equals itself, minus f of x times g of x plus h plus f of x times g of x plus h. So I'm adding it and removing it, that's just 0. I haven't done anything. And then minus f of x times g of x, all of this, of course, over h. So what I just did didn't do anything. However, I can factor. G of x plus h and g of x plus h are in both of these. So we get g of x plus h times f of x plus h minus f of x. And that is just me factoring this part. What if I factor this part? There's an f of x in both of these. So we get f of x times g of x plus h minus g of x. And that's just this whole thing. I just factored. And here it is. G of x plus h factored out, and f of x factored out. I just rewrote it neat. But what else can we do? Well, we got h here. Remember, we're taking the limit as h goes to 0. H never is 0, so we can just divide, not worry about it. I can just distribute the h like so. So now we got these two terms just added together. But I'll do you one better. We got two things multiplied and then divided. I can go ahead and divide this into one of them first instead of the other. So instead of dividing the whole thing by h, I can just divide this by h. And it's the same thing. Multiplying and dividing, you can just change the order. We'll do the same thing over here. Over h is just on this part. So now we're doing the limit as h goes to 0. If you have the limit of something plus something, it's the limit of the thing plus the limit of the other thing. If you have the limit of something times something, it's the limit of the thing times the limit of the other thing. So I can take the limit of this, the limit of this, the limit of this, and the limit of this. That limit times that limit times that limit, and add them. So I can do 4 limits, and then combine them. Now we split the math up nice and easy. The limit as h goes to 0 of g of x plus h, well, that's just g of x. G of x. As h gets closer and closer to 0, it's just x. So there's that one. The limit as h goes to 0 of f of x, h isn't even in there. That's easy. F of x. What is the limit of this? Does that look familiar? That is d dx f of x. That's what that is. That's just the definition of the limit. And over here, what do you see here? D of dx of g of x. Once again, it's just the definition of the limit of the derivative with limits. So in other words, what we get is g of x times f of x plus f of x times g of x. In other words, this is f prime of x, this is g prime of x, and we can rewrite it f of x times g prime of x plus f prime of x times g of x. F prime of x times g of x, or g of x times f prime of x. whichever looks better to you. That proof is just really fun to me. Whenever the chain rule and the product rule both have interesting proofs to me because you pull something out of thin air, stick it in there, it's a valid operation, and then that allows you to massage. It's like turning a building into Legos and rebuilding it into a different building. It's just fun. So anyway, there's your product rule. The rest of the derivative rules, as well as the integral rules, I recommend just looking up. The site Math is Fun. Just Google Math is Fun derivative rules. They have it nice and neat. You can print it out. So for anyone who actually watched through this video, you're awesome. The other people are still awesome, but they'll never know it. But I will be seeing you.